Good morning, everyone. My name is Rahul, and my partner's name is Shrimanti. And together we have designed the early warning alert system for forest fires. There are two main components to our system. The first one is an FPGA board that looks like this. It is connected to an ESP8266 chip through which it hosts a web server. The second component of our system is hundreds and hundreds of sensor nodes like these that will be spread throughout the forest. These sensor nodes consist of an ESP32 chip that is equipped with Wi-Fi and LoRa capabilities, and it's directly connected to a temperature sensor. It will detect the temperature in its surroundings, and it will issue a fire alert whenever a temperature spike is detected. So how does the system work exactly? So here is our FPGA. This is the web server that it hosts, and it's sitting right in the middle of the system. Now this FPGA will be close to the Forest Fire Ranger's office, and anyone can connect to this web server and see the status of the system. Now there will be sensor nodes that will be spread throughout the forest like this, but there will be some sensor nodes that will be very close to the FPGA. These sensor nodes can directly talk to the FPGA using Wi-Fi. But there are other sensor nodes that are spread throughout the forest that can never talk directly to the FPGA. Each sensor node has a unique node ID. Now, what happens when a fire spreads through the forest? Well, whenever fire spreads through the forest, the node that is closest to the fire will detect a spike in the temperature of its surroundings. This node will see that there is a fire incoming, and this node will tell its next nearest node that, hey, there's a fire in my surroundings. So this node, the next nearest node, will now talk to its nearest node, and so on. And through nearest neighbor communication, this information that a fire has been detected at a particular node will be relayed eventually to this node that is directly talking to the FPGA. So, to recap, there is a fire in the forest, and the node that is closest to it has taken some temperature readings, and it is relaying a message that a fire has been detected in the forest. That message will contain the unique node ID of the node that is issuing the fire alert. Let us now see how this system works. I have this laptop that is connected to the web server on the FPGA. So right now, this is the home page of the web server, and you can see that it says that the system is online and there are no fires detected right now. We also have a sensor node here that cannot talk to the FPGA directly, but it can talk to another sensor node that is closer to the FPGA. The other sensor node has the ability to talk to the FPGA. This sensor does not. So whenever this sensor detects a fire, it will just broadcast a message saying that a fire has been detected through LoRa channels, which all other sensor nodes use. And using LoRa, the other sensor node will find out that a fire has been detected and the node ID of this node, along with the temperature reading from this sensor. And that will be passed on to the FPGA, which will then go into alert mode. It will tell the fire rangers, it will show on this system that a fire has been detected. Now, in order to stimulate the fire, we are going to use a lighter, and we are going to heat up the temperature sensor, which is what actually would happen in a forest fire. So the board has detected that there's fire as soon as it woke up from deep sleep mode, and this fire alert has been issued. So the other node knows that there's a fire, and it has told the FPGA that there's a fire. Now let me refresh the web page. Now this is the home page of the web server now that a fire alert has been issued. So the home page has changed, and you can see that it says that a fire has been reported. If we go to the FPGA, we can also see that there are 4 LEDs on the FPGA that are lighting up, indicating that it is issuing a fire alert. Now our job would be to go to the node and verify if the fire was actually, if the alert was actually true or not. And we can tell the web page if it was a true or a false alert. No matter what we choose, that information is now logged on the web server. So in order to see what all data has been logged on the web server, we can go to this particular URL, firedata.html, and we'll see a table of all the fire alerts since the system came online, and the information about the node that issued the alert, information about whether the alert was true or a false alert, and the sensor data, the temperature reading from the sensors that detected the fire and its neighbor. So using these data points, we'll be able to build a decision model when we have sufficient data points that will be able to predict more accurately if an incoming alert is a true alert or a false alert. Okay guys, so that was the early warning alert system for forest fires. We have tried to focus on some key performance metrics in order to improve our system. These are energy efficient sensor nodes and minimizing false alerts. For minimization of false alerts, we are making sure that each sensor node gives its unique node ID, its temperature sensor reading, and the temperature reading of its neighbor along with the fire alert. This will help us by providing us with data points to eventually build an accurate decision model to predict if an incoming fire alert is a true alert or a false alert. The second performance metric that we are focusing on is energy efficient sensor nodes. Each sensor node periodically goes into deep sleep mode, wakes up from sleep, takes a temperature reading, sees if there's a fire in the surroundings, and then goes to sleep again. This will help us conserve battery in the middle of a forest.